I start recording now. Okay. Okay, look at that. You have, for example, example number one. Let's solve use an example one by one. I bring a lot of example. Example one. You have a polynomial like that, x cubic plus 2x squared. Putting off the microphone, put mute. Everyone mute. Minus 3x. Oh, let me see what microphone is open. I don't see any microphone. Okay. Suppose polynomial like that. And it's inequality greater than 0. So this is inequality, polynomial. It's a polynomial. Well, a polynomial when the right hand side is a polynomial in this case, or rational when the polynomial is when the function is a rational function, no? And this is inequality. Actually, this is non-linear inequality. And the solution is completely different. The procedure that you can see, or you saw before in the test one. So what is the procedure? The procedure is, okay, you need to guarantee, it's a mandatory, okay, the right-hand side always must be 0. Okay, don't forget this is step number one. In this case, actually, of course, it's the first example. This is easy. I put 0, no? But in other examples, no 0. You remove or you move to the other side. In order to the right-hand side must be 0 always. I want to understand why. What is the reason behind this idea? Okay, now, after you focus your attention in the polynomial, in the left-hand side, and your factorization, you can see, for example, is there a common factor? GCF? Of course, yes, Sx. Entonces, x squared plus 2x minus 3. Greater than 0. Now, wow, I see trinomial. Trinomial. What kind of trinomial? It's regular, easy. Open two parentheses. And the combination, I suppose, is 3 and 1, because 3 times 1 is 3, and 3 minus 1 is 2, and the sign is positive 3 and negative 1. Guys, I suppose that you know very well that part. Yes or no?
Yes.
Okay. So you transform the original inequality, gets not clear, unclear, and one is a little bit more clear because we factorization the left-hand side and the right-hand side is 0. Okay, what is the next step? The next step is temporary. You convert the inequality to equation. I know that this is not the same, of course, but this solution helped me to understand the solution of this inequality here. So it's easy because when this is already factoring, each factor is equal to 0. So x is equal to 0. This guy is x plus 3 equal to 0. X plus 3 equal to 0. Que es obvio que es negative 3. And x minus 1 equal to 0, que es obvio que es positive 1. Entonces, this value, 0, negative 3, and positive 1, is a critical value. It's the technical name, critical value. And what is the application of the critical value? Well, critical value helped me to understand the solution for this inequality. Now we come back. Now we go to the graphic part. Okay, the solution. So the method, okay, try to explain now. It's a combination, one algebra, factorization, critical value. But using the critical value, you make a partition in the Orient number line. This is my famous Orient number line. So this is 0 in the middle. 0, negative 3 is here, negative 1, negative 2, negative 3. And positive 1. Okay. So we have partition. So we have 3 partitions because we have 3 critical values. And these 3 partitions generate 4 intervals. Okay, one interval is from negative infinity to negative 3, another interval is from negative 3 to 0, another interval is from 0 to 1, and the last interval is 1 to infinity, no? So you select totally arbitrary testing point. This is a new idea, testing point. Testing point is a point, arbitrary point. If one student select different like me, the answer doesn't change because this testing point belongs to this interval. For example, in this interval, I select negative 4. Another student select negative 5. Another student select negative 6, negative 100. The answer doesn't change because any point inside this interval have the same behavior. Well, in the context of the inequality, no? Suppose que I select another testing point here, it's negative 1. Oh, no, suppose que I select another testing point here, que es 1/2, 0.5. I select another testing point, que maybe 2, maybe 3, maybe 4, maybe 5. This is the testing point. And the testing point you evaluate in the original inequality and verification, que es true statement or false statement. So there are one fantastic way to do that. One relatively easy way is create one table like that. You create, for example, you create one chart like that, TP. TP means testing point. And you copy. And you copy. You copy the testing point. Negative 4. Negative 1. Half. And 2. In this case, we have 4 testing points because we have 4 intervals. And now in the column, you write the factor one by one. The first factor is x. It doesn't matter. The order is not important. The second is x plus 3. The third is x minus 1. And you attach one additional column that I call total. Because in this total, we summarize everything we need to understand the inequality. Okay? This is my format for the chart. The rest is relatively easy, but be careful. You evaluate this testing point, negative 4, negative 1, 1/2, and 2, into the each expression, one by one. For example, when you plug in negative 4, it's obvious it's negative. So I don't care the value. The information I need is the sign, if it's positive or it's negative. Negative 4, when you evaluate here, look, let me show you. Negative 4, plugging in here, plus 3, is negative 1. Yeah, I put negative. I don't care the value, I care just the sign. Okay, it's negative. And negative 4 again here is negative 4 minus 1 is negative 5. So I put negative here. And 3 negative multiplication, but actually the factor is multiplication. Negative, 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 3 negative, the answer is obvious que es negative. So this negative I enclose in the circle because it's important. This is the first, or definitely the final answer, no? So you need to complete the table, no? One by one. Negative 1 is negative. Negative 1 here is negative 1 plus 3 is positive. It's positive. And negative, wait. I select, and negative 1 is negative. And so we have, okay. To analyze the total sign, you analyze this idea. Look, you have 3 negative. It's obvious it's negative. So you have 2 negative. I don't care the positive. It's positive. So you have, for example, 1 negative. It's obvious it's negative. So you have 4 negative. It's positive. So the even number of negative, give me the information that's positive. So this is positive. Circle, positive circle. 1/2 is positive. 1/2 plus 3 is positive. 1/2 minus 1 is negative. We have 1 negative is negative. And 2 is positive. And 2 plus 3, of course, is positive. And 2 minus 1, of course, is positive. And 3 positive is obviously positive. And we finish the table. So we almost finished the problem. Now you analyze. We come back at the beginning. The beginning say, look at that. The beginning is our inequality, and our inequality is greater than 0. And to be greater than 0 is synonymous to say positive. See, I change the problem. Suppose I put less than here. Entonces es sinónimo to say negative. Pero no. And this problem is greater than. Therefore, the solution is the positive value in the total column. This and this. Y I just isolate, no highlight. I'm using another color, the positive part. So the testing point, some testing point fail, and some testing point pass. The testing point que pass is the positive. In this example, not always, depending this is greater than or less than, no? So I highlight that part. Negative 1 is here. Therefore, any number belong to the interval que I select totally arbitrary testing point que was negative 1. Pero si another student select negative 2 or negative 2.5, I suppose you get the same answer, right? And 2 also, the interval is from 1, que es the critical value, to infinity. Okay, entonces, what is the final answer? Well, the final answer is, well, okay, paréntesis, and paréntesis, because do not include endpoint. Why I know que do not include the endpoint? Because our inequality don't contain equal sign. Si our inequality contain equal sign, entonces include the endpoint. Entonces, what is my final answer? My final answer is, okay, is paréntesis negative 3, 0, union 1, infinity, que es the interval que I highlight in green color. It's confusing, it's complicated. What do you think? Do you understand? What part is confused? Don't worry, I have several examples to illustrate very well this idea. In the review packet, we solve it more, of course. Any question? Clear or no clear? Unclear or crystal clear, like water? Come on, I want to hear opinion. Nice?
Not yet.
Okay. It's easy because this look like one game. One game. This game have some. This is the number one example. No, a number one example always is easy. And now I want to complicate one different situation that you can find.
Go ahead. Before. Oh, you already erased it.
Okay. Do you want I restore again?
Yeah, please.
Okay. Boom.
All right.
Remember, Ernie, this is recording. And always, I upload the video in Blackboard, Miami-Dade College, and the weekend I upload in YouTube. And don't forget to subscribe in my channel. And please don't hesitate to remind me, Professor, I subscribe and you don't put the 5 extra points. Sorry, because I teaching a lot of class, so I don't remember very well. Okay, let's move on to the second example. Second example bring me new situation. Completely different. Example 2. Example 2 bring me new situation. Suppose this example. X to the 4th power greater than or equal or x squared. Solve this inequality. Wow. Situation number 1 I can see. Right hand side is not 0. And mandatory. Why is mandatory? It's mandatory because right hand side is the level of the C. Suppose C. This is the level of the C. So above the C is positive. Below the C is negative. So C is 0. The level of the C is 0. So this is extremely important. 0 in the right hand side because it's the level. Remember, in the table, when you finish, you put positive or negative. So you need to set up one reference value, and the reference value is 0. Always is 0. Okay? The right-hand side must be 0. Don't expect that any inequality is already create right-hand side 0. So you create. But it's super easy because the only thing that you should do is move this guy to the left. So it's x to the 4th power minus 4x to the 2nd power greater than or equal to 0. Okay, remember to start this inequality, que is polynomial or rational, in another book called nonlinear inequality, right-hand side mandatory must be 0. Okay, the rest I focus it in the binomial, polynomial, trinomial, and the left-hand side I do a factorization. Is there a common factor? Yes, GCF. GCF is x squared. I factor out x squared. We have x squared minus 4. Now I see again, because I factor completed, we have a difference of a square. We have a difference of a square. And the factorization is, open two parentheses, xx to 2 plus or minus. Nice. And this I enclose in the box because this is the inequality that I focus it to solve it. Okay, by the way, it's equivalent to the original, but the original is ugly. Nobody understands anything. This is more clear. Okay, this is similar, a little bit now similar to the example 1. A little bit, except in this we have equal sign, and you see what is the new idea behind this. Okay, entonces temporary, in order to find the critical value, I convert my inequality to equation equals 0. I know that this is not the same, of course, but this is helpful to make partition in the Orient number line, make a decision of the selection testing point, and evaluate the testing point. Okay, entonces es x squared equal to 0, each factor is equal to 0, therefore es x is 0, x plus 2 equal to 0, es obvio que x es negative 2, and x minus 2 equal to 0, es obvio que es positive, no? And this is our critical value, CB. And the critical value we are using to make a partition of the Orient number line. Okay, this is my famous Orient number line. Positive infinity, negative infinity. And we have 3 critical, 0, 1, 2, and 1, and negative 2. So I put the vertical dotted line, similar to the vertical asymptote, but it's not vertical asymptote. Vertical asymptote I put in both directions, above and below. And the partition of partition I put only. This is a style, you know. Now I select, we have 1, 2, 3, 4 interval. I select 4 testing point. Maybe good testing point is negative 3, or negative 4, or negative 5. One good testing point inside this interval is negative 1. Another is positive 1. Another positive 3. I repeat again. If another student select different testing point, the answer doesn't change, because any point inside the interval have the same behavior and with respect to the signs, and the important information is the sign. Okay. So I create my chart, TP. TP, we have 4 minus 3 minus 1, positive 1, and positive 3. And the factor involved in my problem, look here, and the original is x squared, x plus 2, x minus 2, y I attach extra column, que es the total. Okay, in which you summarize everything. Yeah, I try plugging in the testing point into this expression one by one. Be careful, relax, cool down. Let's do it not too fast, because if we make a mistake, maybe. If you make a mistake, your answer is wrong. Okay. You can see in the first column, que es x squared. When you plug in positive or negative value, always is positive. Yes or no? Because because a negative number square is positive. A positive number, of course, is positive. And do you remember that when you analyze the sign, the positive part is not important. The total sign is defined just for the negative. So you have one negative is negative, two negative is positive, three negative is negative, four negative is positive, and so on. Okay, so the positive is not important. Using this idea, when you see okay, it's always positive, you can delete this column. This column have no information. So how do you know, Professor? Well, no, it's complicated. No, it's not complicated. When you see exponent even number like a 2, like a 4, delete this factor. I want to explain in detail in the next example. Be careful because it's a little bit. But this is the base idea. Exponent even, delete. Exponent odd, no, stay. And you evaluate the rest. Suppose negative 3 plus 2 is negative. Negative 3 and negative 2 is negative. 2 negative is positive. Negative 1 is positive. Because negative 1 plus 2, no? Subtraction is positive 1. And negative 1 and negative 1 is negative 3, is negative. This is negative. 1 is positive. 1 is negative. And the answer is negative. Well, let me enclose in the circle the total column because this is the information that I want to check in the last part. The 3 is positive. No, 3 is positive because 3 minus 2 is 1. Okay, so I go back to the original. Original is greater than, and to be greater, I don't care for a moment, equal sign. This is synonymous to say positive. Because the only case true is this and this. The rest is false. The rest is false. Okay. Now, there's a 3 pass. That means that indicate also. Okay, this interval is super good. Negative 3 is also good. This interval is good. No, this is fail because it's negative, no? Okay. This is the most important moment now. Remember, what is the difference between this example and another example? Well, different idea, but the most important idea is that this inequality is no strict inequality. It's a combination greater than or equal to 0. That means, okay, it's positive, I understand, but or is equal to 0. Therefore, the solution of the equation, que is the critical value, belong also to the solution because satisfy equal to 0. Okay? How you indicate that? Well, you indicate that in this case include negative 2, include positive 2. So you put instead of parentheses, you put a square bracket. It's the symbolic way to indicate include this endpoint, but include 0. And 0 is like a one isolate point here, but it's also solution. Wow. Okay, this is what the final answer. Well, the final answer is then, look in the sketch of the Orient number is answer. We have one interval, we have 3 pieces. The first piece is from negative infinity, comma negative 2, bracket, union, and following from left to right. It doesn't matter the order, but okay. But 0 is no interval, it's one isolate point. Entonces, when you have isolate point, the symbolic way to indicate this in mathematics is using curly bracket like that. No square bracket, no parentheses. It's similar to when you solve the equation, that the solution set for the equation is 1, 2, 3, separated by a comma. We're using curly bracket, we're using curly bracket here. Union, because we have another piece, que es bracket. End the story. Any question? No, okay. We are doing okay. Let me see. I want to explain in detail Because remember, I told you that when you have factor que is exponent even, you can delete. This idea is not totally true. In this example que we are doing before, yes. But in general, no. Let me explain it. It's special. I call it special. A special case. I promise in the test, we have one question que is special. How you recognize it's special? Suppose this example, x minus 5. Suppose that I did the factorization. Okay. I ignore this complication. And on the right hand side now is 0. Okay, greater than or equal to 0. Okay, suppose this in this moment. So I move everything to the left. I did the factorization. And I realized, wow, this factor is contain exponent even, que es 2. So the challenge is you delete or you partial delete. No, you totally delete. Chon. This guy is not important. It's not important. If my inequality, my new inequality is just x minus 5 greater than 0, greater than or equal. I solve for x greater than or equal 5. And the answer is expressed in interval notation is bracket 5, comma infinity, no? Because it's greater than. That's it. This is similar to the test number 1. Ahora, what is the problem? The problem is, see, you have, for example, x minus 5. Let's do exactly the same problem, but I change one small thing. Greater than 0. Okay, no equal. O sea, when it's greater than or equal, you totally delete completely. Exactly we are doing in the previous example. Totally disappear. However, in this case, no. I call partial. Partial delete. But what is the partial delete and why? I need to understand the reason behind that. What is the answer there? Well, the answer is because suppose at x equal 4, que es the 0 in the factor que es square, suppose que I evaluate x equal 4 in this inequality. Entonces 4 minus 5, 4 minus 4 square, right? Greater than 0. Bueno, 4 minus 5 is negative 1. And 4 minus 4 is 0. 0 squared is 0. This is 0. 0 squared is 0. And 0 times any number is 0. And 0 is greater than 0. No, it's a contradiction. This is completely false. Entonces, how? Entonces, si you are aware of that situation, then you delete this, pero partial delete. What means partial delete? Well, you copy x minus 5, exactly the same we are doing in the last greater than or equal to 0. You include one restriction, and no 4. And no 4. Because I know can 4 happen a for statement, for conditional. Now you solve this compound inequality. And in the story, okay, compound inequality exactly the same we are doing in the intermediate algebra, no? X greater than or equal 5 and x no 4. Entonces x no 4 means, so remember, as always, compound inequality we are solving graphically. Entonces this is 0 in the middle, 1, 2, 3, 4, and 5. 5. Okay, 5. Now 5 is to the right. No? Let me do auxiliary contraction like that. 5 is like that. This is the solution for that part. And 4 is here. So in 4 we have a hole. This is the represent hole. Represent a hole. But the hole is totally outside this interval. Therefore, nice. I like that. You can't totally delete because the solution is that part. Because in this case, by coincidence, I promise I show you another example. this situation doesn't happen. It's completely different. So the answer for my problem is, okay, nice, is bracket 5. Wait. I changed something. Look, this is greater than. This is greater than. This is greater than, it's greater than here. No equal. I don't know where come from this equal. So no bracket, parenthesis. Entonces paréntesis 5,50. Okay? Let me try to explain it more clear. Okay, partial delete and totally delete. How do you know? It's easy. When there's greater than or equal, or less than or equal, so include equal, totally delete. When it's greater than or less than, partial. You consider the whole. Maybe the whole lie inside the interval, and you consider, and maybe the whole is totally outside the interval, and you totally delete or discard. Let me see another example. Suppose this example is, yeah, I like that. X minus 5. X minus 5, X minus 4 again, square, less than 0. Suppose que in the test, I put this example, it's inequality, a special case, I realize, because we have one factor que is raised to the second power, que es even exponent, good. Now, to say, the challenge is, I totally delete or partial delete? I suppose it's partial because there's no equal, right? So I copy X minus 5, less than 0, and include the restriction, que is X no 4. Because I know in 4 we have problems. Because 4 minus 4 is 0, and 0 is no less than 0, it's a contradiction. I include this, like I call restriction. That is the reason it's partial delete, because you include a restriction when it's no equal. When it's equal, totally delete. Okay, so let's solve the compound inequality. I don't know, see the whole lie inside the interval or no. I don't know, I have no idea. So you solve this inequality first, less than 5. Okay, and this stays the same. And we are doing the part case graphically. Infinity, positive infinity, negative infinity. 0 in the middle. 1, 2, 3, 4, and 5. And this is less than. Less than is, parenthesis to the left. Less than. This is that part. But in 0 we have a hole. Boom. And the whole lie inside the interval. See, lie inside, therefore, actually is the same. So the interval, our solution is wow, here. Okay. Our solution is like that. But you have a hole. And here, parentheses. The final answer is answer. From negative infinity, comma 4, no include 4, of course, because it's a hole. Union, and one piece here, get from 4 to 5. End story. Do you understand the idea for the partial delete and totally delete when you have a factor that contains even exponent? Do you need another example or no?
Yes,
clear?
please.
Yes, please. Okay. No problem. Let's do one more. Look, suppose this example. Suppose x minus 3, x minus 3, x minus 4 again, square. And this is greater than 0. So es partial delete or totally delete?
Partial.
Partial, because no equal. Entonces you copy x minus 3 greater than 0 and x no 4. Okay? So you solving the compound inequality, x greater than 3, and this is a whole, no? And the idea is infinity, negative infinity, 0, 1, 2, 3, and 4. I know, in 4 we have a whole, and 3 is from 3 to the right, because it's greater than, no? So the solution, you highlight like that. Parentheses, this piece, this piece. The final answer is answer 3, 4, union 4, infinity. Okay. Let me try take advantage. I suppose you understand very well this, no? Suppose the same problem, but now is x minus 3, x minus 4 square greater than or equal to 0. This is partial delete or totally delete? This is partial delete or totally delete? Partial delete or totally delete? Come on, guys, help me. Partial or total? Partial or total? Total. Because it's equal. Entonces I ignore totally that part. And my inequality is reduced like that. As x greater than or equal to 3, and the representation of this is similar, but it's easier. This is 0, 1, 2, 3. Entonces es bracket, because include 3 to infinity. And we have no hole. Like that, we have hole in the middle, right? And it's a parenthesis because it's not equal, and this is bracket because it's equal. End the story. Super easy. Any questions? No. Okay. Let's continue the same idea, but another kind of problem. Okay, is when you have rational. Rational, remember, is a division to polynomial. No one only polynomial, no two polynomial divide by. Suppose example 1, 2, 3, 4, 5, 6. Example 6, no? I don't know. Okay, is suppose rational. Rational is a polynomial divided by another polynomial. And to make easy the problem, I suppose that somebody know me do the factorization. This is my inequality. So the new thing is now in the left hand side we have a rational function. Okay, the previous problem we discussing, the left hand side is a polynomial function. Entonces I want to complicate, introduce now rational. Rational is division to polynomial, no? And you are doing the factorization on the top, and you are doing the factorization on the bottom. But no. I did that part because I want to focus on the new part. And after, I promise you see one complete example to illustrate very well the problem. Okay. Entonces, for some of these, you find the critical value. Okay, this is expression. So the original expression don't need modification because satisfy perfectly everything. Right hand side 0, and factorization at the top and factorization at the bottom. So I focus in the critical value. Critical value, we have two critical values. Critical value at the top, critical value at the bottom. Okay, entonces x minus 2, you enforce it to be 0. We have the solution, 0 and 2. This is a critical value. And critical value in the bottom is the same. Is positive 1 and negative 1. This is also critical value. And critical value, as always, help me to create the partition. 0, partition. 1, 2, partition. Positive 1, partition. Negative 1, partition. So we have 4 partitions, so I suppose we have 5 intervals. And you select totally arbitrary testing point. totally arbitrary testing point. For example, I select -2, que is represent this interval. This interval is supposed to be -1/2. This is positive 1/2. Or another decimal or fraction in between 0 and 1, not necessarily 1/2, 1/3, 1/4, 1/5. But okay. 1.5 is perfect, 1.5 is good. And 3 is good, or 4, or 5, or 6 can represent this interval. After the selection, I create the chart. The chart is useful because it helps me to evaluate the function in an easy way. You put it -2, you put -1/2, you put it positive 1/2. 5, we have 5. 1, 2, 3, 4, 5. Wow. 1.5, or 3/2 in fraction if you prefer. And 3 is the 5 testing point. You need to use it in this example. In the column, I put a factor. The factor is x in the top. Doesn't matter, the order is not important. X minus 2, x minus 1. This is too long, but it's not complicated. X plus 1. And remember the super important column is total, in which you summarize everything. Okay, ready. Be careful, slow down. Don't rush. You evaluate little by little. -2 is negative. -2 and -2 is -4 is negative. -2 and -1 is negative. And -2 and positive 1 is negative. Wow. And 4 negative is positive. Yes or no? Because when you multiply or divide, in this case, multiplication and division, but you have 2 negative in the top, down. Division, 2 negative in the bottom, boom. Negative times negative is positive. And negative times negative is positive. Positive divided by positive is positive. Okay, so you don't need to analyze this, not necessary. You see 1, 2, 3, 4 is even, is positive. 1/2 negative is negative. -1/2 and -2 is negative. This is negative again. And -1/2 plus 1 is positive. And we have 3 negative, the answer is negative. 1/2 is positive. 1/2 is negative, but 1/2 minus 2, 2 is bigger. 1/2, this is negative also. And this is positive. 2 negative is positive. 1.5 is positive, of course. 1.5 here is negative because 1.5 minus 2, 2 is negative, 2 is bigger. So subtraction, put the sign of the bigger number, get negative. 1.5, oh, is positive. And it's positive. We have 1 negative, is negative. And finally, 3 is positive, is positive, is positive, and positive. Frequently happens that situation when the last is positive, but not always. It's so big as positive. I come back at the beginning because I don't remember very well my original inequality. Oh, my original inequality again is greater than or equal 0, que es sinónimo to say positive. The true statement is this. True, true, and true. So basically we have 3 intervals, no? Basically we have 3 intervals. What interval was in the testing point -2 pass? And 1/2 pass. And -1/2 fail because it's negative, no good. And the last one gets 3 pass. I highlight this interval. And the blue interval is the solution for the inequality part. But what happened with the equation part? The equation part includes the 0, the critical value, of the top part, que is 0 and 2. And never the 0 of the bottom part because it's undefined. Remember, division by 0 is undefined, therefore it's no solution. So in 0, we have bracket, included. In 2, we have bracket, included. But in 1 and -1, no bracket, parenthesis included. What is my final answer then? My final answer is from negative infinity to negative 1 parenthesis union bracket 0, 1 parenthesis union bracket 2, infinity. Final answer. That's relatively easy. Just the same, but the new thing that you need to know is that when there's combination, inequality, and equation, you include inside the solution the zero of the top part. Suppose another example I bring now. No, this example is similar. Well, this example, suppose it's greater than. Now, si it's greater than, no, without equal, entonces everything in parentheses, and that's it. Everything in parentheses. When it's equal, you include the zero, and the polynomial you include all the zeros. But in the rational, no, because division by zero is impossible, and you include the zero of the top polynomial, not the bottom. Any question? Okay, let's move on to the one more example. One more example of this. Okay, so you have some question, everything okay? Do you follow me? This is easy. In my opinion, this is easy. You have to practice, of course, and the homework. Remember, guy, the thing that I apply in any course that I teaching is, okay, I present the lecture, you understand a little bit, you study by yourself because it's online, doing the homework, and it's natural, you are a student, and one example, you're stuck, you don't understand very well, you email me, and I try to help. I help you immediately. I reply, like you take a picture of the example that you don't understand. I solve in one piece of paper. I take a picture. I send back to you. And also, you can use in the tutor service. So I suppose that you know very well how, no? In the homepage of the Miami-Dade College, you can get inside the learning assistant, something. I don't know exactly what is the name, but there are a lot of tools waiting for you to solve any problem. So ask for help. This is the idea in the university and college, because this is hard. This is not high school. And here, you need help. So you don't ask for help, so now, and you don't know, so you don't expect good grade. Okay? Don't worry. By the way, I teaching this class again in the spring. No. But you need to pay the money again, and you need to spend time with me again. No. I suppose that everyone get good grade, at least pass. But you need to study. Suppose the last example of this part. Okay, this is inequality. This is a rational inequality. How do you know it's rational? Well, because it's division, no? We have top, we have bottom, numerator, denominator. But in this case, intentionally, I don't put the right-hand side 0. This is extremely important. And the test you can see one example similar to this, in which the right-hand side is not 0. So what should I do? Well, step number 1 is move everything to the left. Because I need right-hand side 0. This is super important. Right-hand side must be 0 to start any problem of this. Okay, no but. Now I need to condense this left-hand side. I need to condense it, not in 2 fractions. No. In only one. In only one condensing fraction. And this is a classical problem of the intermediate algebra, no? Okay. First of all, you find the least common denominator, but before that, you factorization. I can seek a factorization any expression and the bottom. I can seek in this case the great common factor is 3, x minus 3. Let me write again. 1 over x minus 2 minus 2 over 3 x minus 3. Less than or equal to 0. Y I focus in the left hand side because the right hand side is super, it's 0. I don't care. I focus it in this. So in order to condense it in only one fraction, you find the least common denominator. Least common denominator is, I repeat several times when I teach it, intermediate algebra. You have several factors. In this problem, we have x minus 2 as a factor, x minus 3 is another factor, and y not 3 is another factor. We have 3 factors. And the least common denominator is the collection every factor. Bueno. Si you have repetition, well, so you take the majority of them. But otherwise, no. So in this case, okay, it's obvious that the least common denominator is everything together. Is x minus 2, x minus 3, and y not 3. Right? 3 I want to put in the front. Okay, now in order to find the top bar, you divide 1 by 1, least common denominator divided by each denominator and multiply by the corresponding numerator, no? It's the idea. You divide, for example, let me try to do here, 3, x minus 2, x minus 3. You divide it by x minus 2. Okay, you divide, the formula is least common denominator divided by denominator 1, multiplication by numerator 1, que es the corresponding numerator, no? When you divide this, divided by this, it's obvious that x minus 2 is cancelled. Look at that, it's a common factor here. And stay alive 3 times x minus 3. Multiplication by 1, que the corresponding numerator is just 3 x minus 3. Minus, this minus is this minus. When you divide this, again, que is the LCD, 3x minus 2, x minus 3, divided by denominator 2, is 3x minus 3. It's obvious que this is cancelled, I stay alive only x minus 2 times 2 times x minus 2. Everyone follow me in this algebra manipulation? Everyone follow me?
Yes, Professor.
Eso, bueno, I know que you know. We repeat several times this and you understand very well and you do very well in your test. The rest is baby algebra. Distribute the property and combine later. Let's do it. It's 3x minus 9 minus 2x plus 4. And the denominator stays the same. I don't touch. 3x minus 2x is 1. And negative 9 and positive 4 is negative 5. Divided by the rest stays the same. I don't touch that part. Less than or equal to 0. Oh, and this is the new expression, que es equivalent, it's the same, but you manipulate algebraically to make easy. The right-hand side 0, right-hand side 0, and we express everything in the left like only one, not two, one fraction. So this problem is very, very similar to the previous problem we are doing. Okay, of course, I give you a nice way, right-hand side was 0, and the I factorization, the top and the bottom. But no, in this case, I need to apply some algebra, previous algebra, to reach this idea. Look. Okay, this is my original inequality, ugly, nasty. And this is my new problem. It's relatively easy. I have one question. Pay attention, please. I have one question. Do you believe I can delete this 3 or not? No? Yes or no? This tree is completely delete or no? Oh, no, no, professor, no. I need to write. Come on. What do you think about this? No idea? Totally lost?
Mm,
Come on, you express your opinion, no? Maybe it's wrong or maybe it's right.
no, I don't.
No. Joanna is no delete now, please. Why? I don't understand why.
Because
Another opinion. Everyone understand que no? No delete?
no delete. Don't
No
use
delete.
no
N
delete.
says no delete, please. No delete because I make a mistake. N, I have bad news for you. You can delete. Yeah, I want to explain why. The reason is, do you remember que we delete or partial delete the factor que contain even exponent? Do you remember that we can delete? Yes or no? And 3 is positive. So when it's positive, it's not important in the inequality. The important inequality is when it's negative. Entonces, any factor que es always positive, que es positive 3, do not apport. Okay. The idea is you can stay 3, but this is totally irrelevant because it's positive. Suppose que you delete to simplify the thing, and the answer stays the same because do not depend of the positive guys, only of the negative guy. Now. Okay, do you understand this or no? Any? It's okay? You
Yeah.
see, no. Any positive value in the inequality do not apport any information. Another way to see, another way. Look, another way. Suppose 3 again. Suppose que I multiply by 3 the entire left hand side and multiply by 3 the entire right hand side. This 3 and this 3 is cancelled. So it's invisible 1. And 0 times 3 es 0. Okay. Entonces es obvio que these 3 do not apport any information when it's positive. But I have another question. Suppose que in the problem, no in this problem. This problem I know que es 3. I delete. Suppose another problem que es negative 3. You can delete or no? You can delete this 3 when there's negative.
No.
When there's negative, yes or no?
No, it's important.
No. When there's negative, no. Well, we can, but in a smart way. Because you know, when you multiply by negative 3 here, and negative 3 here, okay, this is 1, let's delete totally, because 1 is invisible, yeah. And 0 multiplied by 3 is 0, but you know, when you multiply one inequality by negative number, what happened with this inequality sign? It's switching, right? Okay. Suppose another hypothetical. I know that this is not my problem. I try to discuss in any bearing, any options that we can find. Suppose que es negative 3. Bueno, you delete, but when you delete, you need to change this sign, like a greater than or equal. Okay, more clear now? Okay, forget about this. Let's focus in the solution. This is the beginning now of this problem. Now you find the critical value. The critical value is the 0 of the numerator and denominator. Es obvio que es 5. Es obvio que es 2. Es obvio que es 3. This is my critical value in that problem. I do the graphic part. The graphic part is important, guys. 2, 3, 5. Suppose 0, 1, 2, 3, 4, and 5. Partition. Now selection, 3 critical, 4 testing. Suppose 1. Suppose 2.5. Suppose 4. Suppose 6. And 1. es el testing. After the selection for the testing, you create the chart and evaluate. Evaluate TP 1, 2.5, 4, 6. And the factor involved in my problem is, doesn't matter the order is not important. X minus 5, I put in this order, you put in all the order, but the answer doesn't change. Okay, look like that, my chart. And now evaluate. 1 is negative. Guy, I suppose that you understand very well where I come from this negative, you know? Mentally, I plug in this one here. Look, 1 minus 5 is negative 4. I don't care the value, I care the sign. I put negative here. 1 here is negative again. 1 here is negative. 3 negative is negative. 2.5 is negative. 2.5 is positive. Because 2.5 minus 2 is 0.5 positive. 2.5 here is negative. 2 negative is positive. I enclose in the circle because this is important information. The last one, total. This is negative, this is positive, this is positive, it's negative. 6 is positive. Positive, positive, is positive. Okay? Entonces, what is the true and what is the false? What is good, what is bad? I come back at the beginning. My inequality, I don't remember, is less than. And to be less than or equal to 0 is synonymous to say negative. So the true statement is this and this. Okay, in our graph is in 1. So this interval. Remember, 1 was totally arbitrary testing point guy select, but our interval starts at the endpoint is 2, from negative infinity to 2. And one more, we have 2, 3, and 5. Because 4 pass. Then we have, well, the last part is the endpoint. The endpoint, I come back again to the beginning. Our inequality is a combination of equation and inequality because we have equal. That means that the endpoint of the 0, sorry, of the top arc 5 belong to the solution. The 0 denominator, no, because the 0 is undefined in the denominator. So 2 and 3, parentheses. But 5 no, 5 bracket. And the final answer is from negative infinity. From negative infinity. Comma 2, parentheses. Union, parenthesis 3, comma 5. Bracket. End story. Any question? Any question? Okay, entonces let's move on to the last topic in college algebra of the test 3 course. We are talking about test 3, que es relatively easy, is like a linear system of equations, a system of linear equations. So we come back to this. We saw this in intermediate algebra. Well, the new thing in the college algebra is in college algebra we are working in 3 dimensions, in 2 dimensions and 3 dimensions. Let me recall first 3 dimensions and the most important system of linear equation. And I suppose you remember at least the name of the method that we studied, que es substitution and elimination. Substitution and elimination. Let me start first by 2 variables. Example 1, super easy. X plus 2y equals 7. This is equation number 1. x minus y equal 4. Equation number 2. In this example, it's obvious that the best way is using substitution. How do you know that? Well, when the one equation, at least one equation, contain coefficients 1 or -1, is super fantastic substitution. So I can see in the second equation, that by the way, is the easier, in my opinion, no? I can, for example, isolate the x. So I copy x minus y equal 4. And why no? I solve for x. I move y to the other side, 4 plus y. And this expression substitute in another equation here. Entonces we have no x anymore, is 4 plus y plus 2y. This 2y is this guy, equals 7. Entonces, in this moment, we have one equation que contain only one variable, que es y. Entonces, you using elementary algebra, you combine later 4 plus 3y equals 7. And so for y, 3y is equal 7 minus 4. And 7 minus 4 is 3. Divided by 3. Divided by 3. Y is equal 1. Okay, but I need the other pair solution. Y is equal 1, and in order to find the x value, it's easy. Use substitution in either equation. The equation that you want, that you select, the answer should be the same, or must be the same. But of course, I take the easier equation, in my opinion, is this. Because x is isolated, waiting for me, and 4 plus 1, because y is 1 is 5. Now the solution is the point 5, 1. Because x is 5, y is 1, and the solution is the other pair, 5, 1. I want to recall in this system, we have three possibilities. Unique solution, infinity many solution, and no solution. In 2D is super easy. So in 2 dimensions, because we have two variables, x and y. It's super easy visualize geometrically this idea, because each equation represents a line. This is the famous x, y plane, 2D. Let's see what happens in 3D. Well, in 2D is super easy because each equation represents a line. Suppose a line like that, bam. And the intersecting is the solution. And this example was 5, 1. But we have another possibility in which the lines are parallel and never meet. Therefore, no solution. And we have another possibility, as the last one, in which there are perfect coincidence in between the line. This is one line, gets one equation, another equation is exactly the same, so we have infinity many solutions. How do you know? Well, using algebra. This is the geometric interpretation for the problem. But using algebra, we can find that. I bring two examples to illustrate very, very well. In 2 dimensions, okay, we have a non-solution or infinity many solution. No? How do you know that? Using the algebra. The algebra indicates you this. Not necessarily do the graph. You can, if you want, using Desmos, maybe. But no. Okay, let me go to example 2. Guy, I suppose everyone follow me because it's super easy, this, no? Suppose in this moment, we are in MIT 1033, no? So far. Entonces, AX, yeah, Tico. Okay, 2x, AX minus 2y equal to equation number 1. Suppose this example, 4x minus y equal 5, equation 2. Okay, this is a system. Normally we're using the color bracket to indicate that this is the system. So it's not one equation isolated, no. This and this is the mathematical object that involve two equations. Okay, so I can see, wow, again substitution because I can see that the coefficient here is -1. So I take advantage. You take the equation 2, I copy again. Yeah, I solve for y. It's 4x. I move y to the right hand side, I move 5 to the left. Okay, and this expression is y, a substitution in the first equation here. So we have ax minus 2 parentheses, because this is y, que this expression gets 4x minus 5. So these two multiply whole thing. That is the reason I open the parenthesis, no? Equal to, yeah, equal to. The rest is easy. Apply these three with the property. So ax minus ax, because 2 times 4 is 8, plus 10 is equal to. Wow! And you see here a contradiction. Look at that, look at those. Okay, you can see we try to solve x, but we cannot, because positive a and negative a is cancelled. And we get this stupid statement, que es 10 equal to, que is totally false. So what is the interpretation of this? I tried, however, it was impossible. The reason is that this system has no solution. But when you try to solve it, where you cannot, and you get the contradiction, this is the indicator that it's no solution. And I suppose that we are doing this line are parallel in two dimensions. Never meet, we have no common point, therefore no solution. This is the indicator. Okay, no solution. Okay. Everyone follow me so far? I want to raise the board. Okay, good. Let me go to another example that you see infinity many solution. Look. Infinity many solution. No. Oof, too much. Okay, suppose this. Okay, it's 3x minus y equal minus 2. This is my first equation. And my second equation is 6x minus 2y equal -4. Equation 2. Okay, this is my system. Again, I can see again one more time. Okay, we can apply substitution because I can see in the first equation that the coefficient here is -1. This is easy. When there's no -1, you can, of course, but it's more complicated because you introduce a fraction, and the fraction is complication. No. I hit the fraction. I copy again equation 1. I try to solve for y, that the variable can contain +1 or -1 coefficient. So 3x plus 2 is equal y, and you substitution this expression in the another equation that is here, I suppose. Here, in the y place. So 6x minus 2 times, parenthesis, 3x plus 2 should be equal to -4. I copy that. I apply these three with the property. 6x minus 6x minus 2 times 2 is 4 equal -4. Entonces, again, you try to solve it, but we cannot. Because disappear, suddenly it disappear, the variable. But the difference now is that you get true statement. Maybe 0 equals 0, -4 equals 4, 100 equals 100, true statement. So the interpretation is we have infinitely many solutions. Because the line are totally coincident. I want to show you now. Look, it's obvious it's totally dependent system because you come back at the beginning and you multiply the entire equation number 1 by 2. 2 times 3 is 6, 2 times -1 is -2, and 2 times -2 is -4. So this is, when you are doing graphically, this line is the same because there is a totally dependent. That is the reason we have infinity many solutions. Okay, entonces easy, guy. You try substitution. So you get the answer, it's unique solution. So you don't get the answer, you have the possibility. You get totally false statement, that means no solution, or true statement that means infinity many solution. Okay? But substitution is good. I like, I love, but sometimes it's weak. Therefore, I recommend elimination method. Elimination method is more powerful, is more apply in more than 2 dimensions. I want to explain one elementary example of the elimination. Elimination. This is my first equation. Okay, 2x plus 3y equal 12. This is equation 2. This is the system. But I don't see any coefficients in front of the variable. Guess 1 or negative 1. Wow, no, no, no. No, entonces I need to apply elimination. Elimination, what is the key idea for elimination? Elimination. What is the key idea for elimination? The key idea for elimination is that you have, for example, same coefficients. Suppose negative 12y and positive 12y. And when you add in this is 0. This is elimination idea. Okay, so you need to enforce the situation to get this goal. For example, you multiply the equation number 1 by 3, this is a factor, and you multiply the second equation by 4. I don't know exactly what happened, but something happened because 3 times negative 4 is negative 12, like that. And 4 times positive 3 is positive 12. Entonces it's ready for elimination, at least the y. This is the only way to do that? No. There are many ways, but you need to make a decision only one and do it, no? So 3 times 3 is 9. So you rewrite the equation number 1 after the multiplication by 3. Okay, by the way, it's the same because I prove okay, when you multiply one equation by one number, it doesn't matter if it's 3, 4, 5, the line is the same line, doesn't change. So 3 times 3 is 9, minus 12y equal 3. This is my equation number 1, new. Okay, by the way, it's equivalent. It doesn't change. The equation number 2 is 4 times 2 is 8. 4 times 3 is positive 12. Oh, good. I like that. And 12 times 4 is 48. This is my new equation 2. And I am ready to add in equation 1 plus equation 2. Come on. Go ahead, go ahead. You have asked me a question? No? Okay, you adding by column. The X column is 17. The Y column, boom, it's gone. That was the intention, no? Elimination, look. And in the right-hand side, we have 51. Divided by 17 both sides. X is equal to 3. Because 51 divided by 17 is 3. And now in order to find the Y value, use substitution in either equation. Well, I select the first one. I don't know why, but I select the first one in my paper. Okay, look. Suppose I select the first one. Yes, 3. Look, this one. If you select the second, it's okay. But I need to do at least one, no? Selection, make a decision. So I know that X is 3. Minus 4y equal 1. 3 times 3 is 9. So 4y is 9 minus 1 is equal to 4y. This is 8. 4y divided by 4. Both sides is 2. Y is 2. And the solution is the order pair, in this case, 3,2. Elimination, guys. Elimination. Fantastic, eh? Okay, fantastic elimination. Okay, let me complicate your life. 3D. In college algebra, this was to review, quick review. I suppose in your moment we studied this, we spent 2 or 3 lectures and we solved it in 10 minutes. But now in college algebra, we are doing exactly the same, but in 3 dimensions. 3 dimensions mean 3 equations and 3 unknown. Okay, suppose this example. I solving at least 2 examples today. X minus 3y plus 3c. You see, 3 variables, 3 unknown, x, y, z equal -4. This is my equation number 1. 2x plus 3y minus c equal 15. Equation 2. Nice. And 4x minus 3y minus c equal 19. Wow. 3 equation and 3 unknown. The unknown is x, y, and z. And when I finish that, I need to find the triple order x, y, z, que represent the solution of this. Okay? Listen to me. Pay attention, careful. I want to explain the procedure. It's a little bit different, What is the idea? The idea is you have 3 equations, but you pair 2 equations. Suppose I pair equation 1 and equation 2. I copy again. The organization is extremely important in mathematics. Okay, I rewrite again equation 1 and equation 2. Yeah, I pair this equation because I want no. Because I see okay, y is ready for elimination because it's negative 3y and positive 3y. Okay, this was a coincidence, good coincidence. Okay, I create when I did this example for you because I don't want to complicate your life. And the test may be yes, but no now. I want you focus. Okay, you pair 2 equations and you eliminate 1 variable. In this case, when you adding equation 1 plus equation 2 by column, this is 3x, 1 and 2. This is cancel, it's gone, no y anymore. And this is 3 minus 1 is 2, 2z equal 11, no? 11 because 15 minus 4 is 11. And you get this equation, I call equation number 4. In this equation number 4, we have x and z, and y disappear. No y anymore for a moment. Okay. Now, in the next step, you pair. I pair 1 and 2. I pair, for example, 2 and 3, or 3 and 1. Doesn't matter. But you are smart. You pair 2 and 3 because this is the most important thing I want to explain today. If in the first couple of the equation you eliminate y, when you select the second couple, you must eliminate y also. So you eliminate x, you are in big trouble because you don't eliminate the same variable. Okay, you need to eliminate, mandatory eliminate the same variable. I copy the equation 2 again. Look, because the pair, the couple of the equation now is 2 and 3. I copy 4x minus 3y minus c equal 19. This is equation 2, this is equation 3. Now, ready. When you add in equation 2 plus equation 3, this is 6. This is gone, exactly the same of this. See, I eliminate y here, I eliminate y here. Mandatory minus 2z equal 34. 34. This is equation 5. This is equation 5. It's too long, guys. Sorry. Wait a second. Oh, no, it's okay. It's okay. Now, you pair 4 and 5. Get the new system. I copy here. 6x minus 2z equal 34. 34. And this is equation 5. Oh, in this moment, I have similar problem that we are doing in 2 dimensions. 2 variables, x and z, 2 equations. By the way, it's ready for elimination because 2 is positive and 2 is negative here. If you add in equation 4 plus equation 5, it's 9. It's canceled. Wow, I like that. And it's a 45. Divided by 9, divided by 9. Therefore, x is equal 5. Well, at least I have in my hand the x value. The x value. I need to find the y, I need to find the z. But what equation am I using? Because I have 5 equations. 1 equation, 2 equation, 3 equation, 4 equation, 5 equation. It's obvious that you can use 4 and 5. Because 1, 2, and 3 contain 3 unknown. Well, you know 1 is x equals 5. But if you plug in 5 into the 1 or 2 or 3 equation, you have 2 unknown. No good. So I recommend using the equation 4 or equation 5. I don't know, I prefer equation 4. I don't know why. Because I substitution 5 in the equation 4. So 3 times 5, because I know that x is 5 plus 2z equal 11. And this is 15 plus 2z equal 11. 2z is equal 11 minus 15, que es negative 4, ¿no? Divided by 2. Es obvio que z is equal negative 2. I need to find the y. Well, okay, see, I need to find the y. I cannot use anymore 4 and 5 equation because 4 and 5 equation do not contain y. Remember, y was the variable I eliminate. So you're using equation 2, 1, 3. In my paper, I using 2. You can use in either equation. Suppose I using 2. 2 equation is, let me copy again, 2x plus 3y minus c equal 15. No? It's the equation 2. I just copy again. But I know that x is 5, 2 times 5, plus 3 times y, I don't know. I don't know why. Minus z is here negative 2. Be careful with the sign. We have minus of the equation, and we have the minus of the value. Double minus. This is 10, 3y. This is plus 2 equal 15. Okay. We combine like that. 10 plus 2 is 12. 3y plus 12 equal 15. So for y, 3y is equal 15 minus 12. Okay, 3 divided by 3. Y1. Okay, so what's the answer? The answer is the triple order. X, y, z in the alphabetic order is 5, 1, negative. Wow, too long. Look, take a picture of that. Es system que contain 3 equations and 3 unknown. Let me summarize quickly the idea. You select 2 equations, a couple, 1 couple, and you make a decision to eliminate, for example, y. In other example, not necessarily y, it's another variable. Done. And you get the 4 equations that contain x and z, no y anymore. You select another couple. Pero mandatory, you need, see, in the first couple you eliminate y, and the second couple you eliminate y. So in that moment, we have 2 equations, 2 new equations, 4 and 5, that contain only 2 unknowns, is x and z. And you know how you solve them. You solve it exactly the same we are doing in intermediate algebra. Elimination, eliminate 1 variable, and now we go to the back substitution, go back. When you get 5, it's obvious that you, in order to find the c value, you evaluate in the equation 4 or in the equation 5, and never in the equation 1, 2, 3, because the 1, 2, 3 contain 3 variables, and you are doing back substitution. When you have in your hand x and z, plugging it into the either equation 1, 2, 3, I select the 2, I don't know why, and you get the y value. Clear or confusing? I know it's too long. But remember, guys, we are taking Collet algebra. Collet algebra is hard. And some students need to take 2 times and 3 times. I have in the roster, in your roster, a student can take the second time. I know it's hard. Question. Everything okay? You feel good? Ismael, Inaya, Chance. Okay.
Yes, sir. Thank you.
Eso. Bueno. Alicia, Robert, Pierre. Okay. Let me try at least one more. Okay, in the review I promise. Okay, I solving another, no? Oh, see, one more. Okay, let me try. Come back to the whiteboard. Okay, suppose this example. Okay, 2x minus 2y plus 3z equal 6. This is my first equation. 4x minus 3y plus 2z equal 0. And the last equation is minus 2x plus 3y minus 7z equal 1. Equation 3. Okay, remember the procedure. The procedure is you pair two equations, but you pair smart, not stupid. I can see quickly, no, if you, for example, take the equation 1 and equation 3, we can eliminate the x part. Let me copy. Organization is important. I need to make a decision. There only one way to solve the problem? No, there are no infinity, but we have a lot of possibility. I select equation 1 and equation 3 because I can see at least the x part is ready for elimination. Now, see, it's not ready, so I need to enforce it. No? You cancel out this. When you add equation 1 and equation 2, this is gone. This is just y because it's 3 minus 2 is only 1. And this is minus 4c equals 7. Okay, I call equation 4. Now I take equation 1 and equation 3 in the first couple. I take the equation, oh, you say, no, professor. Now I can see now the equation 2 and 3 is ready for elimination y. No! Because you eliminate x in the first couple. You must eliminate x in the second couple. Mandatory. Okay? But I use 2 and 3. I need to do some modification, I suppose. 4x minus 3y plus 2z equals 0. Minus 2x plus 3y minus 7c equal 1. This is equation 2, this is equation 3. And I have to mandatory, see, in the first couple, I eliminate x. I need to eliminate x here. So I multiply the second equation, the equation 3, by 2. By 2 positive 2 factor. Because if I multiply by positive 2 factor here, this equation become like that. 4x by 2, see, by 2, no? Es 2 times negative 2 is negative 4. 2 is 6y and minus 14. C equal to, no? Okay, and this is my new equation 3. It's equivalent because when you multiply by a number, it's the same equation, no? So you forgot this. That was history. I'm ready to combine 2 and 3. This is the x is cancelled. 6 minus 3 is 3y. Minus 12. 14 and 2 is 12. It's negative. Equal to. And this is my equation 5. And this is my equation 5. And you put together 4 and 5, and let's see what happens. I have no idea. I copy 3y minus 12c equal to. This is equation 5. I copy together of this. Entonces now, wait. You apply your common sense, you apply elimination one more time. Don't expect que it's ready always. In this case, I propose you, for example, multiplication by -3. You multiplication by -3, the equation 4, the entire equation 4 by -3. What is my intention? My intention is to get -3, and -3 and +3 is ready for elimination, no? So multiplication -3, so we have -3y, so -3 times 1 is -3, and negative is +12. And this is 21, no? -21, and this is my equation 4. New equation 4 after the multiplication. I forgot this for a moment. Ready. Because I create to delete this y part. But look at what happened. Wow, amazing. Something weird happened. It's deleted the y and deleted the z. Therefore, we have nothing in the left-hand side, 0. In the right-hand side, we have -19, no? -19 because it's 21 and 2, subtraction, -19. And this is completely false step. That means that this system have no solution. Okay, you see in the review, another possibility is infinity many solution, but today we have no more time. I suppose it's too much for one day, no? Okay. Remember, I want to send after the class, when the class is over, I want to send to you the actual test 3, and you start working in the test 3. Okay, the question that you understand, you try. And Monday we are doing the entire review for the test 3, and everything is due Wednesday, next Wednesday. Okay, by the way, this day is, let me see in the calendar, it's 25, November 25. It's due because this day we start the topic for the test number 4. Any question, guy? Super. We are the best in Miami-Dade College. Yes or no? Come on. Answer me. Yes or no? Yes. Okay.
Always.
Yes. You can leave and study. Okay?
Okay, thank you, Professor.
No pleasure.